Hello, this problem has been asked in GATE 2023. The problem is that in the Nyquist plot of the open loop transfer function GSHS is equal to 3s plus 5 divided by s minus 1, corresponding to the feedback loop shown in the figure. So this feedback loop shown in the figure, the infinite semicircular arc of the Nyquist contour in S-plane is mapped into a point at. So in this problem, it has been asked that we have to find the mapping of this Nyquist contour in S-plane, and this is mapped at a point in the S-plane. So what should be the value? And the options are given as GSHS is equal to infinity, GSHS is equal to 0, GSHS is equal to 3, GSHS is equal to minus 5. So before we begin to solve this problem, let us having quick recap what is Nyquist contour and how it helps in plotting the Nyquist plot, and with the help of Nyquist plot how we determine the stability of closed loop system. So what is Nyquist contour? The Nyquist contour is a closed contour in the S-plane which completely encloses the entire right hand half of the S-plane, and this contour is mapped to determine the encirclement of the point minus 1 plus j0. So the Nyquist plot, uh, this so the Nyquist contour is divided into four sections. We can see this by seeing this figure, and this Nyquist contour is mapped into GS plane, and by combining all these mappings we get the Nyquist plot, and from the Nyquist plot we find the closed loop system stability, right? Now we will see the mapping of all the individual sections. So for the mapping of section 1, in this section 1 the value of omega ranges from 0 to infinity, and the contour will be drawn in GSS plane with respect to the above range will be a polar plot of the G J omega H J omega. So the how we are going to do the mapping of section 1, we have to draw the polar plot of the open loop transfer function gh j omega. Now we will see the mapping of section 2. For the section 2 we can see that the range for this section varies from plus 90 degrees to minus 90 degrees, and for mapping of this section we we have to apply this, we have to replace sy r into e to the power j theta and take the limit from r to take the limit r tends to infinity. So by applying this condition we map the section 2 into the GH plane. Now we will do the mapping of section 3rd. So from the Nyquist contour we can see that section 3rd is just the inverse of section 1. So as in the section 1 we mapped by making the polar plot, so for the section 3rd we will do the mapping by making the inverse polar plot. Now we how we are going to map the section 4. For mapping of section 4 we can see that this this Nyquist contour of the this Nyquist contour has a semicircle of 0 radii, and the range of the section varies from plus 90 minus 90 degrees to plus 90 degrees, just it coming to the starting point. So how we are going to map this section? We have to just replace the s by epsilon into e, e to the power j theta and take the limit of epsilon tends to 0. So it's just similar to the mapping of section second. Now combining all these mappings we make the Nyquist plot. So taking the summary of this what we have seen, we can see that for the section 1 we have to make the polar plot, and for the section 2 we take the limit r tend to infinity of for the function gh into gh r e to the power j theta, and for the section 3rd we have to make the inverse polar plot, and for the section 4 we just apply the condition that is similar to section second, but in the section second we take the limit r tends to infinity, but in the fourth section we take the limit epsilon tends to 0, because for the section second we are having infinite semicircular r, while for the section 4 we are having very small semicircular of 0 radii. Now with all these mappings we make the Nyquist plot, and from there we, we just apply the Nyquist stability criterion, and from there we get the from there we can find that whether the closed loop system is stable or not. So what is this Nyquist stability criterion says that it says that for a closed loop system to be stable, the Nyquist plot of open loop transfer function must encircle -1 plus j0 point as many times in counterclockwise direction as there are number of open loop poles in the right half of S plane. So just keep this Nyquist stability criterion, just remember this and just keep it in mind. So in this problem, it has not even asked about the stability criterion, and not we need to find the whether the system is stable or not. In this problem, it has asked about that mapping of the section second. So let us solve this problem. So what are the points we are given? We are giving the transfer function, open loop transfer function GHS is equal to 3s plus 5 divided by s minus 1, and it is given that section second is mapped into the GHS plane. So for mapping of this section, the condition will be, we have just seen that limit r tends to infinity gh r e to the power j theta. So on simplification, we get this expression on putting replacing the s by r into e power j theta. So we get this expression, and now we take r common in both numerator and numerator, we get this expression, and on simplifying we get 3 as the answer. So the final answer for this problem is C. Thank you.